Okay. Okay, so let me share my screen real quick. And hope you guys can see my screen and I get some acknowledgement on that. Yeah. Okay. Yeah. Yeah. Great. All right, so let's deep dive into this, guys. So today, what I'm going to cover is one of the fundamental issues with the Gen AI bubble that we are in, and how can we navigate through this? So the title of this discussion is Empowering LLMs with Knowledge Graphs. And why knowledge graph? So we'll be covering basically the basic things about RAG, what we understand about RAG, the initial power problems with the RAG, and how we are evaluating it, and what are the different kinds of metrics we are using to evaluate it, and then what's the motivation behind talking about knowledge graph. Then we'll discuss a little bit about knowledge graph, what it is, a foundational elementary stuffs, and then how RAG and knowledge graphs can be combined together. So once we are done with this little bit of theoretical session, so that I can set up a foundation about why we are talking about knowledge graph combined with LLMs, then we will deep dive into a playground. You guys might have received a GitHub repository, which looks like this. And it is basically, it has the code that we'll be using, and so this, you guys can use this particular link, which is open in Colab, and we don't have to set up anything. Everything is ready to be used in the Colab. We just need OpenAI token and we should be good to go. And in the end, I would appreciate if you guys can keep following through with me. And this is the section where we will collaborate. And I have already pasted some of the knowledge graphs that I have created. And you guys can create your own and share it with us. And I'll paste it so that we can create our beautiful graffiti of knowledge graphs together. So that's the objective of today's discussion. Let's populate as many knowledge graphs possible, um, which should look beautiful at the end, hopefully. All right, so let's get started. So let's start and talk about RAG systems and what RAG is, and how does it work as a high level, because I'm sure most of the people, most of the audience here are in some way familiar with RAG. It is the most popular thing in the AI industry. So why RAG? So what happened in the AI, especially in the natural language world, was like we were having queries and we were designing hard-coded systems, which would basically give us some response, like chatbot with the intents and entities, which was not scalable enough. So researchers in the community, AI community, came up with this intelligence compression method where they can ingest lots of language data, internet data, and combine it together into a contextual format so that it can give us some response. And that's what became an LLM, large language model. So we can see the one objective of LLM is to hallucinate. So by giving so many examples, now it is only doing is trying to hallucinate every next token after one which is in the previous. And this hallucination works surprisingly so good that we kind of start making sense. So that was what RAG came up and got really popular, but it came up with a few challenges, like they suffer from hallucination, the information is missing, the latest data is not there, and all those kinds of things. So we designed another approach to make it work to solve some of the problem, was naive RAG systems, where we take our domain specific documents, chunk them out, convert it into vectors, and then we query into this vector database and retrieve the most relevant vectors, which is similar to our query. And then we get relevant response. We give this specialized context to our LLM to give us a response. So it did help in reducing a little bit of context, or a little bit of hallucination, but not very well, because still the objective of this particular module, which is large language model, is to still hallucinate. And researchers and community have devised different kinds of chunking strategies to distribute this data efficiently so that we can still find relevant information. There's a really nice paper, which I have a link over here, And they basically employed another thing which was using reinforcement learning in the process. So I'll talk about that a little bit. So this is the initial first iteration where you have input and output of a RAG system, where you give some input and then expect an output. And then we evolved with that and call it chain of thought, COT, where you let LLMs hallucinate a little bit in a specific contained environment so that it generates a couple of responses. And then in the end, we evaluate and compress and consolidate those results, which was still not that good because it was still hallucinating. So we came up with another approach, which was COTs with self-consistency. So instead of doing one chain, we added little bit more of chains and aggregated more. So it's more like inspiration from neural networks as well. Like we have hidden layers and how many nodes we need. We are just using same metaphor here to distribute our probability of getting our results more closer to what we want. And then we came out to be tree of thoughts, same thing, but in a tree structure. So we can have multiple paths if figuring out what direction solution needs to go. So it's just broadening the spectrum of data we are looking into. And then we got GOTs, which is graph of thoughts, which looks like a graph representation, not exactly graph models, but the structure is graph where directed graph where each of these trees could be interlinked between each other as well. And the last one was the XOT, which is, I think, still very experimental, where they employed policy value network, where you give rewards and on every actions that a model makes if it is good, and made that into more like self-learning kind of a mechanism. So these were this couple of things that came into the picture, added a little bit more context to the LLM to build sustainable RAG systems. But still, we are still lagging. We are not addressing the core problem, because all these small modules that we see here in between, these are still doing hallucinations. So we are trying to do as many hallucinations and consolidate into one form where we can expect to get a more decent results. Sometimes it works, sometimes it does not. And data without context is useless. This is why we are doing all this thing. We are providing as many data context over here so that the end result could be more reasonable. So once we figured this out, that okay, RAG is something that we are going to use, so let's address the problem, the elephant in the room. So Andhra Karpathy, I am sure you know about him. He's like one of my initial guy who I've been following for long. When he was doing his PhD, in one of his talk, he talked about he wanted a language model in 2018 or maybe in 2017. He wanted to compress all the information from one novel and then have all that context into a novel and then use that as a chatbot. But at that point, we did not had any LLMs. So he wrote a Twitter post about this, the hallucination problem, where he also makes the same thing, that hallucination is all that LLM does. And in this direction, I think we just need to figure out how to deal with this. And basically, we labeled this whole thing that is just trying to find information and trying to predict something as a hallucination. So coming out of that, there were some methodological scientific ways to evaluate how LLMs are hallucinating and when and where. So this is one of a graph from popular evaluation technique called needle in the haystack. And what we are seeing over here, this is for the GPT-4, that x-axis has a number of tokens. So since we have heard about like LLMs coming out to be with bigger context length, so this is the spectrum of context length, and this is the depth in which we have the information. The facts are hidden inside the documents, in the middle of the document. So it becomes a little harder for LLMs to retrieve those information efficiently. And we can see as we increase towards more context, and in this particular section, even though GPT-4 is a combination of different LLMs, it is still failing at some point in this region where it cannot retrieve the high accuracy results. So it degrades after some point. And even though GPT is very efficient, We have seen with the entropic cloud models that the whole region on the other side of the spectrum is even worse. So this dictates the problem that as soon as we start increasing the length, the retrieval of this information, it degrades after some point. So this is a problem. Yeah. So I just wanna maybe one word description. If you guys tried to resolve any of, if you have experienced any hallucination in your use cases, and what techniques, what methods you guys tried to employ to fix the hallucination. Yeah, so we are seeing prompt engineering. Yeah, that's a way where we navigate our LLM to behave in certain way. Nice. Re-ranking, proper prompting, testing DSPY, which is a very good method, really good. Yeah, DSPY is really interesting, very programmatic way to navigate through this problem, and also part of a very good best practices. Re-ranking is also a very scientific way, splitting the smaller task, RAG and re-ranking, really cool. Measuring the hallucinations, I would like to understand how do you measure hallucination? Like if you have any matrix that you used to measure them, or did you try to design your own custom matrix to come up with how can we measure the hallucinations? If you guys want to chat on the Zoom, you can do that or respond there. Yeah, feel free to interact. This is an interactive session, people. Another LLM. So yeah, that's funny. I have done that. I'll say I'm guilty about that. I've seen, okay, Llama 2 is not working fine. Let's move to something else, and then let's try Llama 3. Quick and easy fix. Sometimes it works, sometimes it's not. Split the to smaller tasks. So that's also when we talked about chunking strategies. That's really useful as well. Really good. Self-check GTP. So Artem says that measuring the hallucination with methods like self-check, that's really cool. Like you can have GPT or a different LLM to evaluate different LLMs. Yeah, feedback loop with domain experts. This is really interesting. Bodan mentions that he's using feedback loop. It's really interesting to see people started using feedback loop, which is really important, I would say, because this improves the model itself, and it's really necessary for any and every enterprise solutions, I believe, because domain expertise are something that LLM lacks. Fine tune, yeah. Great. These are all really good results. These are really good methods that I'm seeing here. Okay, let's move on to our conversation and dive about knowledge graph a little bit. Okay. All right. So we discussed about the RAGs. We talked about the problems of the RAG. Now let's talk about the motivation. What is it about knowledge graph and LLM? So from this is my understanding, and it can be different from different people, and me working for on knowledge graph for a couple of years, this is what my understanding about knowledge graph is. It's a symbolic representation of the facts and factuals in a human level comprehensive manner that I will express in detail in further. And LLMs, they are basically neural forms that benefits in machine comprehension. We use this technique as compressing knowledge compression mechanism. And when we combine these two things together, we get a digital twin actually. So knowledge can explicitly be represented as triplets, which I'm going to talk about in a couple of minutes, and implicitly can be expressed as embeddings, the information, the knowledge in the LLMs. And this harmony combination makes it better thing altogether. So let's deep dive into this keeping this motivation in mind, let's deep dive into the knowledge graph and see how it works. So the one thing that I want to mention about knowledge graph is that knowledge graph treats relationship as first class citizen. This is one of the most important fact about knowledge graph, that uh, in the world, in real existence, ourself, everything is related. And there was a really nice quote where it said data itself means nothing, but if the data is connected, then it becomes knowledge. So connected data is what we want, and this is what knowledge graph helps us achieve over here. So to form a knowledge graph, this is the fundamental representation of any knowledge graph in its core. And it says that there is a node which has some labels, some attributes, and it's connected to another node with some labels and attributes using a relation, an edge. And this edge can also have an attribute. So for an example, in our natural language form, there is a noun which has some adjectives, and there's another noun which has adjectives and it's connected by the verb. So for instance, we have fox. We all know this phrase, fox jump over the dog, right? So the fox was the noun and it had some attribute, which was the speed, which was quick, and the color brown. So this whole thing can be converted into a representation of fox as one knowledge, and another was the dog, um, which is was lazy. Its attribute was lazy, the mood. So it, and the relation between these two things, these two entities, were that fox jumped over the lazy dog. So this is how we represent a very basic information in a knowledge graph. And once we start combining these relations together, which we will do in a couple of minutes, then we will see that how this whole thing converts into a beautiful representation of information. So let's talk about graph representation learning. What is graph representation learning? When we do knowledge graph, we are trying to compress or connect this knowledge together in a graph format. So we have these nodes, which I just talked about. So these are the nodes that we have these blue dots, and then we have edges which connect these dots. And once we do it in iterative form, we create the graph. And these graphs could be represented by itself as a visual component, or can be used to retrieve information, because one thing is connected to another, like we see in the Facebook graph, or Amazon graph, or we see in a Spotify graph, that they have one song or one people connected to another person who is friend of, and so on. So this is how it grows. And on this particular graph, what we can do further is to graph neural networks, similar to like deep learning, where we have convolutional neural networks. Similarly, we have graph neural networks, where the only difference is that it takes graphs as an input instead of taking text, and instead of taking videos, images, and we are feeding graph to this neural network. And then we perform graph neural network operation, which basically does edge detection, or it could be optimized to do something else like classification as well. And once we do GNN, it yields these embeddings, which we can visualize, which we will do again in our session. And we can visualize these graphs, embeddings created together. So all the similar kind of things will be close together, as we see in LLMs as well. And these embeddings will have concepts and relations attached together. As I said in the beginning, that knowledge graphs treats a relationship in the first class citizen. So all the relations are preserved in this particular embeddings. And a couple of years back, when I was creating some knowledge graph for one of an enterprise client, this was the graph that got created at the end of the whole exercise. And it looked really beautiful, as you guys can see. And then those days, I thought actually this could be part of the NFT market. So let's take the data, convert into beautiful visuals, and convert it to NFTs. But I did not do that. Okay. So let's talk about the combination of RAG with knowledge graph, how we are doing, and what how does it accompanies the formation of RAG systems. So RAG focuses mostly on localizing the information from huge amount of text, which are contextually similar. So this is what RAG does. Give me something similar what I'm asking for, and show me 5 kinds of similar things and summarize it in a well way. And on the other hand, when RAG power with knowledge graph is all about utilizing the underlying structure, the relation that I mentioned about before, and then utilize this concept and relations together to get more precise information. So here's a small representation of what a knowledge graph and LLMs have pros and cons. And we can see that LLMs pretty much hallucination. It's a black box, implicit knowledge. You really need to fine tune these over time, and it's expensive. And the pro is that it generalizes well. The generalization of this whole LLM is really interesting, which is why it is so fascinating. And when we talk about knowledge graph, it has structured information, it's more accurate, everything is interpretable. You can connect the dots to see what information is where, but it lacks generability, unseen facts. It's one of the biggest problem with knowledge graph, that there can be facts which are unseen, the new information, which could be ingested easily, but when you create a knowledge graph, maybe you did not inherit that information. So this is some pros and cons. And when we talk about adopting, so you would be asking like, okay, all good, like, but how do we practically do this? So this is a small high level overview of like how a RAG looks like and how we are going to incorporate our knowledge graph into a RAG system. So let's say we have a prompt, we embed that into query embedding, we do search and retrieval, ask the LLM and vector databases to give us the documents which is relevant, send it to the LLM, get and retrieve a response. So we all know this whole process of RAG. So the way we adapt knowledge graph into the whole flow is we still do the prompt, we still do the embedding, search and retrieval. Instead of using a vector database here, we do a vector search on the knowledge graph that we just created. And as we said, as I mentioned, that it preserves all the structured information. So it still gives us the vector set of vector representations that we need, and it could be sent it to the search and retrieve module to the LLM and get a response back. So we are basically asking this whole RAG system to give us more confined context on which LLM can respond. So we are more looking towards the factual information with an interpretability concept in mind. So it's also one of the foundational pillar of knowledge graph, where we make these systems explainable and understandable. Great. Hope this was clear, and I'm not going super fast because we need to cover a little bit of code. So I would just ask you guys to answer another question for us to talk about the on the fact that listening to all these knowledge graph things and ideas, what I've been talking about, what kind of use cases do you guys envision where you can basically utilize creating a knowledge graph systems? So let's talk about that for a minute. So it could be any use case, whatever problem statement you are working on. Do you see a fit of knowledge graph there? Do you guys see any way you want to use it? Maybe from the explainability point of view, because you're retrieving information from legal documents, maybe, and you want to pinpoint where exactly you're extracting. Cool. So code generation. Nice. Yeah. We need a lot of structured way to have code bases. There are lots of structure. So it really makes so much sense to use knowledge graph in code generation. That's a good one. Recommendation system. So this is a very popular one actually for creating knowledge graph, and Amazon, Spotify, Uber Eats, they use knowledge graph as a foundational element that can be used to create recommendation systems. So Alex is asking a question in the chat that some work paper of using knowledge graph with images, videos, and sound. So this is also one of the really good question, Alex, first of all. And this is another thing that makes knowledge graph one of the next technology to be using for multimodal capabilities. Because imagine if you can embed text, create a text as a node, you can always take an image, convert it into, let's say, a vector, and store that as a node. So it can work for any modalities. Take an audio or a video, convert into vector or represent it into some form, and then you can create a node. And now let's say if you have an image which is vectorized, you have an attribute for that. It's a image of a pizza. That's an attribute, and it's connected to, let's say, Pizza Hut, which is a pizza provider. So you can create knowledge graph using any kind of modalities, and any modalities can play a role into this. There are some of the works that been coming up. There is one that was launched by Intel, I believe. They have created a multimodal knowledge graph out of multiple modalities. I can share the link with that. Thank you. Thanks for the question. Okay, let's see what other people are talking about. Property extraction fraud detection is a good one. I have seen some of the banks trying to use knowledge graph because banks have a hard time to keep up to date with the fraud. So I have worked on a couple of use cases where they needed to update their rule bases to detect the frauds, and you really need factual information over there. So that's good. Comparison and reasoning. Yes, you can see these knowledge graphs, thoughts connecting together. So you can reason very well that, okay, why this answer came up to be and why not the other. Chatbots with extended knowledge base. Perfect. This is like most of the enterprise use cases, I believe. So people want their own knowledge, their handbooks, their knowledge repositories, which has some specific keywords in the domain, like medical domains. They have very specific keywords and cannot be found in an articles on internet. So that's a really good use case as well. Great. These are all like really practical use cases that you guys are talking about, and happy to see all these use cases, which means I did a decent job explaining a knowledge graph to you guys. All right, so let's jump into the next phase now, and I will see where we are. Let me share my screen. Okay. Okay, so to recap real quick, we talked about knowledge graph, we talked about the problems with the knowledge graph, we talked about the RAG, we talked about the problems with the RAG, motivation behind building the knowledge graph, a little bit of one-on-one on knowledge graph, and how do we adopt it and understand the combination of RAG. So now we are going to jump into a code phase where I would need you guys to follow a little bit with me so that you guys can also create some beautiful interactive knowledge graphs with me. So we will do a couple of things like install the packages as usual. We all do, import them, configure the environment, create a database, uh, build a knowledge graph, do some prompting to optimize our knowledge graph generation using LLM, and then do some visualizations and query this knowledge graph. One thing I want to add here, that if when so what this is has been one thing that I have observed in the domain of knowledge graph. Not many people talk about knowledge graph because eventually it ends up trying to use some kind of a knowledge graph database, which is like Neo4j. So it does not really need to be that way. You can use any kind of systems, and it's just like any vector database. You're just generating vectors, and it can be a binary file that you can use to retrieve information from. So you don't have to bind yourself with any tool. Try to pick whatever best you can. And in this particular use case, I'm using Kuzo database, which was recently released a couple of years back. And no, it's just a random pick for me to use this. So yeah, just making that. And yeah, let's get into the code. So I have shared this GitHub repository. If you guys go into this GitHub repository, you guys have to click on this button which says open in Colab, and this notebook will basically pop up in the Colab like this. Things I'll talk about these imports are basically I'm using Kuzo as my graph database, which will be one of the thing that I'm using. Another thing I'm using is Llama Index, similar to LangChain. It could be any pick. You guys can pick whatever is your favorite tool. For this particular experimentation module building, I have used Llama Index. UMap, I'm using it for visualizing the embeddings. Network X and Plotly, and these 3-4 modules are basically to create our visualizations around our graphs and embeddings. Okay, are we doing good? Everyone, just give me some thumbs up or sign so that we can proceed further with this. Everybody's on the code page, they're able to run it.
Yeah, maybe it just was too fast to do slow. Just let us know. Maybe Rahul just need to repeat something or to show how to add a token or where to go.
Right.
Don't hesitate, unmute and ask questions, or you just need to repeat something.
Like you mean like this, extend?
It's too small, right, Artem? It's hard to read.
Oh, is it? Okay, so I'll zoom in a little bit. Okay, perfect.
Thanks for confirmation. Okay, anyone need to finalize any kind of steps, or we can just move forward?
All right. Okay, so let's assume everybody's happy with their imports and all the imports have worked for their code bases, and let's try to use our secret. So if you have already used this secret over here, this name OAI needs to be replaced over here, which is your secret, whatever is your secret, but my is called OAI. So I should be able to use this set as an OpenAI key environment variable. And then we define our LLM. So one important thing about defining LLM here is if you see temperature to be 0. So we need this to be 0 because we don't want LLM to hallucinate even in its own existence, like the initialization part itself. So we want it to just give us straightforward answers without any creativity, because we are building this very deterministic system at this point where it relies only on facts and knows and does not creatively do anything at this point. Those things can come later on if we want to, but right now we just want it to be temperature 0. And you guys can pick depending on what is your document looks like, how big or broader the documents are. You can define the chunk size to be something else. But in our case, we're just going to use 512 as a standard practice. Great. Now, if you guys have initialized this, you can give any name to your knowledge graph. This can be a unique name that you guys want to pick. My knowledge graph is called my KG1, and we give this name, execute that, and then we define 2 things. So this is the Kuzo database, which takes this name. This will create a folder. If you see this icon over here, you can see a folder will be getting created, which will be named as whatever your knowledge graph is called. And this Kuzo database is basically stores all the information in the nodes and the metadata and the attributes and everything. So it will have all those indexings stored inside these files. And then this Kuzo graph store is basically the connector with Llama index with Kuzo. So we are just connecting our graph database, which is Kuzo, with Llama index to work in synergy between each other, so that now Llama index knows that I have to save it in a Kuzo index format. Okay, so let's execute that, and we should have our knowledge graph instance ready. This is the part where now I want you to pick anything of your interest. Make sure that you have some website that you want to use. So you can create a list of websites over here that you guys want to be part of your knowledge graph. Here I have used neuronslab.com. I have used stories, about us, talents, and some Crunchbase data. So you can pick as many documents. The only thing is that if the website has a lot more text information, not the images, then that will be much better. So more the text information you provide is better for us to create this knowledge graph, because right now we are using text modality, inherit all these text from all these websites, and then create our knowledge graph on top of it. And this simple web parser will basically read all these websites, extract all the text from all these websites, and convert it into a document format, which we will use further. Okay, so I'll give a couple of minutes for you guys to use this this placeholder to fill up your URLs, whatever you like, and replace this particular code section with your interest. And if you want to continue with this, then feel free to do that. If you want to add into this, it's also a good experiment to do. Like if you have this website, and if you have a website of your own interest, you can actually create this, and in the knowledge graph you'll be able to see how neurons lab ideas and concepts and things are connected with your things. So that's why it is so powerful, that it can create these realistic relations between things. Like if you're working on AI, and if you have a portfolio of your own, so you can basically see how you're working on AI connects with the Neurons Lab website, and in what ways. So that will be really interesting thing to see later on. Couple of things I'll talk about meanwhile you guys are picking up your websites and interest URLs. You can utilize, basically I'm talking here about creation of these triplets. So what we're doing with in this instance is basically asking LLM to take all this document text and convert it into triplets. Triplet is basically what I showed before. No, noun connected with another noun using verb. So which in terminologies of knowledge graph, we say subject, predicate, and object. So or source, target, and relation. So which is what we want from this LLM to do, as behave as a knowledge graph triplet creator, and then create subject, predicate, and object. So we will utilize LLM to basically take this huge chunk of information, convert it into triplets wherever it finds entities. So there are a few things about knowledge graph where you identify entities. These entities needs to be connected somehow. So those are the relations. So LLMs are good in identifying entities like names, places, and stuff. Like if you guys remember from old days, we used to use Spacey for NERs, name entity extractions and stuff, which was not easy to build because the repositories, the vocabularies were limited. But with LLM, we have much generalized knowledge that can be used to basically automate that process. So that's what we are gonna do here. Use LLM to create these triplets. And one configurable parameter that you guys can change is how many triplets you want from each chunk. Like if you want to create 4 triplets, 5 triplets, you can pick. And here what I have in the text is basically what Llama Index uses as its foundational default prompt. And we will be basically changing this prompt to make it better. I have tried this prompt, it does not work very efficiently. So I have made my own version of the prompt, which does a little bit of a better job in doing that. So what it does is basically some text is provided below, take the text, extract these many triplets that we are configuring here, and creates a subject, predicate, object kind of a relation, and extract the, for example, like here is a text, then triplet needs to look like this. Here's a text, triplet needs to look like this. And this is the placeholder for the prompt to take the text. And further on, the triplet needs to be generated here. Okay, so let's look into the indexing part of this whole thing. So if you guys can see this, it's a little bit black on top of black, but I think hope it is visible. So what we are doing is taking all these documents from all these websites. We are splitting it into chunks. Once we have different chunks, which is what we configured to be 512 size, we convert these into embeddings, and then create triplets out of it. So and store that into vector indexes. So these are the triplets that we are creating, and with their embeddings, which are their attributes, and store it into vector database. This is the underneath thing operation that's going on that we're gonna see in this 2 line of code. And let's see what this thing is. So this is basically storage context. So this is, we are defining how we are using our storage. So we are using this graph storage, which we defined from Guzo. Fuso connected with Llama, and Llama index is basically connected to create a storage context, and we will be using the storage context to create all this indexing, which is utilized in this knowledge graph indexer from the documents, and these documents that we extracted from the website. And this is one of the parameter which I was mentioning, where you can have as many triplets you want. It will define how many API calls it will do to the OpenAI, your GPT models. Storage index and the service provider. So we use the service provider, or if you can see there. So we created the service context provider, which is our LLM, where we have defined we are going to use the service from LLM, which is our GPT 3.5 Turbo. So that is defined over here. Show progress will show all these things and include embeddings, so that we are also generating embeddings for each of these triplets that's getting generated. And I have commented this thing out, which we will go back to later on. But if you guys execute this stage, you should be able to basically see these embeddings getting generated. And you should be able to see a process node, which should be creating these triplets. And this will take a little while, depending upon how much documents we parsed and how much information we have.
Good.
Okay. So let's move a little bit more, because there's a couple of more interesting things to talk about. This is the prompt, custom prompt that I have created, and it's a little bit better from what Llama Index has by itself. So I have just optimized it a little more. So what I've said, like, as an AI assistant, you excel in extracting structured information, use these many triplets, and create these format. Avoid stop words, focus on the important relations and facts, and triplet needs to be listed like this, and given the text and the triplet. So little bit modification, and this prompting for me at least works better, and you guys can play around, change it a little bit, see if it makes more sense to you guys, and then can create your own triplets. Couple of things to note, like how knowledge graph, how LLM Llama Index works is basically you have to create this prompt template. It can be a normal text in the beginning with these placeholders. Like you can see one of these and one of these here. So these are the placeholder which will be fed into the model. And then we are basically gonna create this particular module which takes the text, and the prompt type needs to be this, which is called knowledge graph triplet extraction. This is the definition from Llama Index, and we have this thing which can be used in place of our template. Okay, so if you guys want to change this, try to change it and execute. And I will move a little further and talk about looking into the knowledge graph. So, okay, what I'm doing here is basically taking the index that has been created by the indexer here and extract all the triplets that are being created, and this module is network X. So as I said, network X is one of the package that used to visualize our graphs. So we are creating our graph object, and this network is basically for the visualization, and we can define some behaviors like gravity and some physics into the graph. So like when you pull and push, so I'll show you that in a minute. And then once you are done with this, you will be basically able to see this. So Artem is asking, can you clarify one more time what is triplet? So triplet is, so let's look into this example. So we are basically representing information in three forms. So we have source, we have target, and we have a relation between source and target. So if you recall in this particular part where I was talking about triplet format, so this is the triplet format where we have noun and another noun which is connected with verb. Yeah. Okay, great. So so that's what this LLM is doing, is creating many instances of this. And if there is, let's say, a noun which is called Neuron Lab, and another noun called AI Practices, and another noun which is connected with something, and another noun which is called noun Neurons Lab, and another node which is called, let's say, AI Best Practices, then Neuron Lab is basically connected to these two things together, because we're creating same kind of source, which I will show in a bit, and it will make sense visually a little bit. So let's look into this graph. And if you guys paid attention, I was using a Neurons Lab website, and this is what we got in the end, a graph which has neuronlab.com, and it has some relations and it has some nouns. So this is a noun, which is entities, and this is a relation which has got some relation in between. This is a Neurons Lab, which is again has some more relations. And if you can see, it has created actually multiple hops. So what does multiple hop mean? So if I'm jumping from one node to another, and that node to another, it's hopping from different nodes. So if I'm on this node, and then if I jump into this node, then there's nothing else connected. So this is one hop. But if I jump from Neurons Lab to, let's say, Expert Steam, then this is one hop. And if we jump to another node, then this is connected, called second hop, like two hops. So retrieving information, two hop. This is very important thing to note in graph structures, because we are hopping from one node to another, and finding relevant information based out of it. And if you guys did the steps in the notebook, then you would be basically able to create this graph for your data set. And this is the representation of the complete knowledge graph that I created. And more the data you add, it will start getting more complicated. You can see these are the triplets. So if you can see, this is one triplet which has been created and is not connected to anything else. Like it needs more post-processing or more information to basically connect these dangling information. But these are also like good information for LLMs to process if we have any questions around that. So Artemis, what is the difference between Neuron Lab node and another Neuron Lab node? Good question. So if you see, this LLM is not smart yet enough. So that's why, like, this is a very naive way to create and fast way to create knowledge graph. You can see it's the same thing, but this Neuron Lab does not has the hyphen in between. So this is why it is a two different text. If we do ask, let's say, prompt it to understand, make LLM to filter out the duplicates, then this whole node will be part of this, and all the things that are connected to this node will be part of one node called Neuron Lab. But that's a post-processing thing that can be done, or a smarter prompt engineering that can be done, so that you can combine the repeating nodes and make it more connected, densely connected nodes. Hope that makes sense. And okay, and here, let's say I want to see AWS, so I can filter out AWS and see AWS articles. It's connected to healthcare. If I want to choose something like Europe, so Neural Lab is located in Europe. And so yeah, we can just play around with this graph. It just looks visually appealing, right? So if you have done this part, I would appreciate you guys to go to this link, which I have posted here. It's a Jamboard, and you can take a screenshot of your thing, of your graph, and you can add it into these sheets. So I can take that and paste it into the Figma file in the end. Whenever you guys are done, you can paste it over here in these different pages, and I'll take it in the end. Okay. These are just small helper functions to compress these folder and download it so that you can keep it with you, because this process utilized LLM, and you don't want to repeat your LLM. So you can compress this and download it into your local so that you have it and don't have to rerun it. So you save your cost for LLMs on GPT models. Now comes the interesting part, which is where we want to query this knowledge graph. And There are a couple of ways to do it, some interesting stuff that I'm going to talk about, and component of explainability. Three ways to basically get response from LLM. We have tree summarizer, refine, and compact. In summary, like tree summarizer is good for summarization. So you have multiple results from the knowledge graph, like multiple nodes and triplets, and then you basically compress them into one representation. The refine is good for detailed answers, and compact is, in short, it makes similar to like refine, but it takes less LLM costs calls. And two big parameters to play around with this knowledge graph retrieval is that you have to define how deep you want to go. When I was talking about multiple hops, so if we say we want to only look into one hop, that means that I am only looking for information about neuron labs till here, just one connection. I'm not gonna look further here because I restricted how deep I want to traverse into the graph. And this will impact the retrieval time. So bigger the graph, more the hop, more the time it takes to retrieve the information. So this is what this parameter does. And similarity top K is basically when we extract information about, let's say if we have a query, tell me something about neurons lab, then this keyword queries vector representation will be similar to all the triplets that we have created. And we will try to condense that. So instead of looking into all the existing possibilities, we extract first, let's say top 5 most similar embeddings. Triplet embeddings, and then only retrieve information from those. So that's what this does. So even condenses the context of the information that we are retrieving from the knowledge graph. Okay, good. Hope that was clear. We will see it in action. I'll show it in a visual way, and then we will play with it. So this is just a helper function to plot all these graphs. You can play with it, change things. It is taking all these edges which we created and basically plotted. So let's do some query over here. And this is what's gonna happen in a nutshell. We are the user, we are asking an LLM to ask some figure a question, and then it will go into the LLM, retrieve the most relevant node, flatten that out, get all these triplets together, as I mentioned, like most similar ones, and then extract a response from there. Okay, so let's ask LLM about a couple of things about neurons lab. What does neurons lab does best? So this is my question, and I can pick between refine, compact, and tree. So I'm gonna use this compact, and I want similar like how many relations I want to look into. So let's just do 1 at this point as a default and wait for the response. So it will basically fetch for the information, solves neuron lab solves real problems. So this is a node, a sub graph that we extracted, and I'm visualizing that. So instead of looking to the complete spectrum of the knowledge graph that we created, we are just looking into what made this LLM to respond this particular thing. The neuron lab excels in providing end-to-end AI consulting services XYZs. But this information was extracted from this particular node. If I increase the similarity 4, so now we are basically asking for 4 connections in the knowledge graph. Give me those subgraph, and now we can see like 4 of these information got extracted. And now the answers are basically articulated based out of that. If I increase it further to 12, then we are going to basically extract information from 12 similar kind of nodes. So you see how we're expanding our domain of information using the knowledge graph, and we can see everything about where it is getting the response from, and then we can just play around with it. And I can go further, like increase the depth to 4, and hopefully it also adds more, but it's not visually possible to see, but it tries to extract all this information and changes the response a little bit based out of what we're retrieving. Okay, so let's see a couple of another question which I had for the, let's see, okay. So I'm gonna ask like, okay, how do we contact neurons lab? And let's just ask this question by reducing the top K, and let me depth feed something. So company Neuron Lab collaborate with, talk to experts team. So it's to contact Neuron Lab, you can visit the website, get in touch option. So it articulated and teams experts in the US and Europe and so on. Let's increase the spectrum a little bit and see if we get something different. Okay, so it's more contents to contact Neuron. You can reach out to the user and get in touch page. Okay, that's good. So you guys can see the fact that you can have much more leeway. So as I extended more of the information, now I can get exact facts from the website, that you have a phone number here and the address, which is not really possible with just using LLMs. It can retrieve information, but not to the fact that it can extract all the relevant facts that you can use. So this is why it is so important to use knowledge graph in a way that it can condense the information for you and give you the factual information. And you can see how it has played a role over here. This is all good. So I think you guys got an understanding about how knowledge graph is actually impacting our RAG creation process and how we are even making it much more efficient. Another parameter that I did not show you guys, maybe let's do a tree summarizer, and it changes the way, like it extracts multiple responses, but it compresses it in certain fashion. So let's say if we can refine it, same information, a little bit variations. Okay, that's much more refined. So you can email them, right? All right. Great. So let's look into some of the embeddings that actually got generated. So here's a code base to see some of these embeddings and like plot them. So we can basically use that index and extract all these embeddings, create a data frame, and this is how the data frame looks like. So if you see, the index looks like triplets. So Neuron Lab is a node, is a relationship, and this is another node. And for this particular triplet, we have this embedding of 1536 size. And let's plot that and see some interesting stuff over here. So this is how our graph embeddings looks like from the knowledge graph. This particular thing is called KGE, knowledge graph embeddings, because it has preserved all these relations in a factual way. If we see, okay, let's see what's on the top of this thing here. So we can see all about Neurons Lab. We can see the node, the source node is in the same color, and the relation is registered in. And we have all about Neurons Lab here on top of, so all the concepts about Neuron Labs are preserved here. This is about neuronslab.com. It has images of something. And this thing is about V, which is also Neurons Lab interview process. It's all about you. So, and another interesting thing is, like, if you see this whole bunch of cluster, you might be curious, like, why there is a whole separate set of cluster over here. So if we go there, this is basically people. So the idea about somebody whose name was extracted here, we can see Lilia, who is a director of business development. Her node is here. We have Lika, which is director of people. We have Dima. We have Artem, head of cloud. So all these people, Jan, for director of delivery. So all these, it understood a relation that these are the people, and has been clustered over in a different space from all these ones. So a little further, but these are all people and the team members, basically. Really cool, right? So this is how it looks like underlying, and we can do so many things, like as people talked about in the previous. We can do recommendations on top of this. We can do clustering, segmentation, and so on. So I know this was a lot, and hopefully maybe not. And I maybe speeded up a little bit, and hope you guys enjoyed this interaction. How can we how can you get a set of entities, nodes from a given dictionary? For example, UMLS medical terms. Okay, so set of entities. Again, like if you, let's say for medical terms, you have uh, even for medical terms, or if you want to use, let's say, legal terms. So in legal process, you have litigation, pre-litigation, all those terminologies. You can basically define that into this prompt. This is why I was showing a custom prompting here, that you can define all those things into a prompt and refine your prompt for an LLM to understand that I want to create these triplets for different entity types, the node types, and then use this dictionary. And also, like you mentioned here, Cyril, that you can use a dictionary. So you can do a post processing. Once you have used, let's say, you did offloaded lots of work for LLM to work on, like creating all these triplets. You can always use your own ontologies, your own dictionaries to post process these triplets, refine it, and then use it further for creating knowledge graph. So there's a huge component of doing post processing. You can always create your own nodes and entities and add it into this index, which I just showed in this index that we have here. Yeah, this index. So you can add your own dictionary information into this index also. Hope that makes sense. All right, guys. Any more questions? Thank you. Boran. So knowledge graph generation is using LLMs, so it's still vulnerable to hallucination. That is correct. And that's why when I mentioned about using temperature to be 0, this will restrict it to hallucinate a lot. And this is not a standard, I would say, traditional way of creating relations. The ontology is generally done manually, but we are using LLMs to basically offload some of these tasks. There is still a lot more work needed to create these triplets, which is more realistic to the nature of reality. So, say there is something related to Apple. Apple is a device, so the relation becomes that it's a corporate. And Apple is red, which is another fact that is it's a fruit. So these relations can vary, and you can always use your own ontologies to define it. So you're right. It's still, we are, since we are using LLM, so it is still hallucinating, but this is just a fast way to create knowledge graph that I wanted to show how it plays a role. You can totally eliminate this process and do an manual ontology creation, which could be like taking an Excel file, and all the rows that have information is connected to the column, and the cells missing the value is not connected. So you can rely on your, let's say, fraud data set, bank transactional data sets, where you have some information and each cell having values for the row could be related as nodes and entities and relations. Hope that answers the question, Bojan. Perfect. Any more questions, guys? These are really good questions. Thank you so much for asking and being so interactive in this part. So yeah, any more questions, any suggestions, any feedbacks, anything that you guys want to know more that I could have covered, you guys can share that as well.
Yeah, sometimes after, like an active brainstorming and making some new things, making a code, making a magic, as it was been mentioned before in the chat, sometimes, yeah, guys need a time to overthink the information,
Right.
and then to ask questions. Yeah.
Yeah, don't be shy, guys. Like, data is beautiful, and we are just connecting the dots between these data. So let's do that. I understand, like with LLMs, there is a big problem that we don't see what is underneath, and getting all those embeddings out, it's a huge vocabulary. The 60 billion, I mean, it's not possible, right? So we have some technology which is explainable to a degree, where we can see all these dots connecting, even in this document that has been shared by Bodan, that we have these relations. So it's not really easy to see these relations when we just ingest this information into LLM and ask it to respond us. So it's really good that we have something. Okay, another question. Are we expecting to see soon fine-tuned LLMs for triplet generation to improve performance quality? Is that interesting in industry academy? So fine-tuning an LLM. So the there's yes and no. There's multiple ways to achieve triplet generation. Like code generation, we have code instruct LLMs, which are specialized only in generation of code. So that itself can be used to generate triplets as well. But if you ask me, just prompting can also do. Fine tuning might not be needed, but there are graph language models which are in talk in academia, which is inherited from, like, okay, let's do graph representation learning where we generate embeddings, and once we have these embeddings we can do all these kinds of fancy things, extract and query facts from the knowledge base. So those are all still in the talk, but obviously it will take a while, I believe, to get into mainstream. But it's a good idea to have at least an LLM. People are still working on creating huge knowledge graph databases like Wikipedia knowledge graph. We have a wiki knowledge graph, but more on the medical terminologies, more on the legal document terminologies. Like, can we have a huge data set on which we can create knowledge graph? So creating the data as a foundation for any model is data. I think we are still on that phase where industry and academia people are still creating these huge data sets, which can be utilized further to create knowledge graphs, embeddings out of it, or systems like LLMs, like large language models. That's my take on it. Yeah, but thank you for that question. It's really, really good.